Okay, before we start this problem, remember on your test, it's not going to say use integration by parts. It's just going to say find the integral of x e to the 2x dx. So I'm going to write something down. I don't want you to write this down. I'm going to do this in green here. This is not the correct way of doing this problem, but this is what I see on the test all the time. A lot of people just get done with the u substitution section and they say, okay, well all we have to do is let u be the exponent. We're going to find the derivative of both sides. Well, the derivative of 2x is 2. Solving for dx, we would get du over 2. We would substitute in for u, and we would substitute in for dx. So this integral would turn into the integral of x, and then it would be e to the u, and then we'd have du over 2. Well, if you notice what happens is we still have x's, we still have u's, so that means integration using u substitution does not work in this problem. And if u substitution doesn't work, we actually need a second method. So integration by substitution does not work. We have to use integration by parts. So let me clean up everything that we just did. Give me a second to take that all away. What we need to do is realize that we have two functions here. This is a product of two functions. The first function we have is x. And the second function we have is e to the 2x. And so we're going to set this up. We're going to have a u. Sorry, let me use the pen here. We're going to have a u. We're going to find the derivative of u. We're going to have a v. And we're going to find the derivative of v. Okay? So what we have to do is we have to pick which one of these is u, which one do we want to take the derivative of, and which one of these is dv. Because if you remember, integration by parts is the integral of u dv equals u times v minus the integral of v du. Okay, so that's the integration by parts. So we're starting off with one of these is u and one of these is dv. So we always want to make u the one that when you take the derivative it gets easier, and we always want to make dv the more complicated of these two. So it seems to me that the more complicated of these two would be e to the 2x, and the easier of these two, or the one that I take the derivative of and makes it easier, is x. So this is my guess as to what u and dv are. So what do I do? Well, to find du, I differentiate, and to find v, I integrate. So it's going the opposite directions. So again, to find du, I'm going to take the derivative with respect to x, the derivative with respect to x of both sides. And if I found the derivative with respect to x, I would have du dx equals, well, the derivative of x is simply 1. But then I want to solve for du, so I need to multiply both sides by dx. So I'd have du is 1 dx. That's going to be very important for us, okay? So we know that u is just x, and we know that du is 1 dx. We want to remember that. Okay, so dv, we said, was the more complicated of the two. That was e to the 2x. So what do I need to do to figure this out? Well, I need to integrate both sides. I need to integrate both sides of that equation. So what is the integral of 2x? And by the way, every time you have dv, you need to include the dx here. Every time you have dv, that includes the dx. So let's include that in there. Okay. So what's the integral of e to the 2x dx? Well, that's a simple u substitution. Let u equal 2x. Solve for the integral of e to the 2x, and you end up with, well, it seems to me when I integrate it, I end up with 1/2 e to the 2x. And then it would be plus c, but we don't need to worry about the plus c until the very end of this problem. So don't worry about that. Okay, so what did we have? We had dv is e to the 2x dx, and then we have this v, and this v here is 1/2 e to the 2x. Again, I got that integration by doing u substitution. Do the side work if necessary for you, okay? All right, so look at the rule here. It says the integral of u dv, which is our original integral, is u being just x, v being 1/2 e to the 2x, minus the integral of v, again, that 1/2 e to the 2x, du just being 1 dx, okay? So let's plug this in. Our original integral was x e to the 2x. Using integration by parts, we would have u, which was simply x, times v, which is 1/2 e to the 2x, minus the integral of v, The integral of v would be 1/2 e to the 2x du, which would be 1 dx, and there it is right there. So there's uv minus the integral of v du. Clean this up a little bit. This would be 1/2 x e to the 2x, I guess. Doesn't really matter how you want to watch that. And I'll clean this up a little bit. This would be 1/2 times the integral of e to the 2x dx. So we still need to integrate. This is a multi-step problem. We still need to integrate. But the nice thing is we've already integrated e to the 2x dx. We did that over here when we integrated dv, and we know what that integral is. So it seems to me we're getting 1/2 x e to the 2x. That's my first part. Then I'd have minus 1/2, and the integral of e to the 2x is 1/2 e to the 2x. Now, since we've done our last integral, we need to add our arbitrary constant, that plus c. So I'm ending up with 1/2 x e to the 2x minus 1/4 e to the 2x plus c. Quite honestly, that's fine by me. It depends. There's multiple ways that we can write this. For instance, both of these do have an e to the 2x in common. We could technically pull out 1/2 or 1/4 as well. Depends on which one you want to pull out. But certainly we can at least pull out the e to the 2x. So if we pulled out the e to the 2x, I would have 1/2 x minus 1/4. And then we'd have the plus c. So that's my integration using integration by parts. It's e to the 2x times 1/2 x minus 1/4 plus c. Again, you might see that someone tries to pull out a constant. Quite honestly, any of these last two lines would have received full credit in my class. So how do we know we're right? Well, again, anytime you have an indefinite integral or anytime you've integrated, you can always check your answer by finding the derivative. So I ask you now to find the derivative of this. You are going to need to use the product rule, but very quickly you're going to see that once you find the derivative of this, you do get the original function that we started with, the original integral or integrand that we started with. So please double check that by doing the derivative now. Let's move on to example 2. So example 2 is a little less intuitive. Again, we do have a product here. X times the natural log of x. We do have a product here. And when we have a product here, first thing you try to think of is, can you use u substitution? I don't know what you would try using on this one. If you tried u substitution, try it. I'm telling you it doesn't work. So if u substitution doesn't work and isn't going to work, then you need to try integration by parts. So we have u, we have du, we have dv, and we have v. Okay? So usually what we do is u is going to be the one where you take the derivative and it makes it easier. dv is going to be the one that you have to integrate and you want to make it the more difficult of the two. So if I'm using that logic, I would think that u, and again, let me come in here. We have two different functions we're looking at. The first one is x, the second one is ln of x. So one of those two things is u, one of those two things is dv, because we're going to be using integration by parts, which says the integral of u dv is equal to uv minus the integral of v du. That's our integration by parts formula. So if I use that logic, u is the one that you take the derivative and make it simpler. I would think I would make that x, and I would make dv the more difficult, which is natural log of x. But here's the issue. Taking the derivative of x, very, very easy. We know the derivative of x is 1. But what's the integral of the natural log of x? We have no rules for that. We have nothing to help us integrate the natural log of x. So when it says make dv the most complicated, what it means is make dv the most complicated that you know you can integrate. I can't integrate natural log of x. A lot of you might say the integral of natural log of x is 1 over x. That's not true. That's the derivative of natural log of x. Remember, you're trying to integrate the natural log of x. So this choice, u being x and dv being natural log of x, will not work because I cannot integrate the natural log of x. So what do I have to do? I have to try it the other way. Let's try letting u be natural log of x, and let's try letting dv be x. Okay? So again, how do I find du? Just find the derivative. Well, what's the derivative of natural log of x? Well, it's 1 over x. And then I'm going to tack in that differential dx here. I always have the differentials on both of the derivatives. So how do I get the next one? If I start off with dv, I need to integrate it. So what's the integral of x? Well, that would be, what, 1/2 x squared, or x squared over 2, plus c, but we don't need the plus c in this case. Okay, so let me do some highlighting so you can see this. We have now made u equal to the natural log of x. We've made dv equal to x dx. Okay. We have du here, which is 1 over x. And we also have v here, which is 1/2 x squared. So let's go back up to our original formula here. The integral of u dv is uv minus the integral of v du. So I'm going to use some color coding here. Color code each one of those. So u was blue, v was the yellow, the integral of v was the yellow, and du was the green. Okay, so that's what we're going to end up with when we plug this into the function. So let's hear, u would be natural log of x, v would be 1/2 x squared, minus the integral of v, which again is 1/2 x squared, times du, which is 1 over x, and then you have the dx. So let's do some simplifying here. I'll write it as 1/2 x squared natural log of x, minus, I'll pull out that 1/2, so 1/2 the integral of, well, x squared times 1 over x is simply x. That simplifies, right? X squared over x is just x. Dx. Well, that's a simple integral to do by hand. So this is 1/2 x squared natural log of x minus 1/2 times, well, the integral of x is x squared over 2. Then we have our plus c. So this would be 1/2 x squared natural log of x minus 1/4 x squared plus c. Again, I would accept this as the final answer on the exam. But many teachers would try factoring this out a little bit. You certainly could pull out an x squared. You could also pull out a fraction if you wanted. I don't really care about the fraction so much. So this would be x squared natural log of x, or 1/2 natural log of x minus 1/4, and then you'd have the plus c on the outside. Okay. How do I know this is right? Well, how do you know anything's right when you integrate? You take the derivative of it. So if I took the derivative of this using the product rule and checked, I would end up with the final answer of x times the natural log of x.